All right, well, so far in this unit, all we've talked about are systems of equations, meaning we were looking for the one point that would make both equations true. What we get into in this section, and in the book, this is section 6.5, we get into what are called systems of inequalities. In which case, if you guys think back to Algebra 1, this is where you graph the lines or graph whatever, and then you shade one direction or the other. You're looking for the multiple points or the many points that make the equations true, or make the inequalities true, sorry. So our goal in this is to find all the points that make one of the inequalities true, like this one, then find all the points that make this one true, and the solutions are the points that they have in common, the ones that make both true. And so what I'm going to be doing throughout these notes is graphing each one in a different color, and then looking for where the colors intersect. So on this first one, if I want to graph x is greater than or equal to 2, well, pretend like it's just an equal sign. Graph it like you're going to graph a normal line. So over on the coordinate plane, I'm going to draw the line x equals 2, right here. And now I want to shade one side of this or the other. And so I want to shade all the points that would make this true. I want to shade all the points that the x-coordinates are greater than 2. And so if you think in terms of would it be to the right or the left, well, all the x values greater than 2 are to the right. So everything over here make the first one true. Those are all the points that make the first inequality true. But I'm looking for all the points that make both true. So now I want to graph the second one. And I'm going to use the color red here. And I want to graph y is greater than or equal to negative 1. So that's going to be a horizontal line at negative 1. Here. And all the points greater than or equal to negative 1 are above that line. Everything up here. So everything in red make the second one true. But I'm trying to find out the points that make both true. And if you notice, that happens right here in this top right corner. So the way I signify that that is my final answer, change this to be a little whiter. I'm just going to color that section in real dark. And that signifies that these are all the points that would make both of those inequalities true. So the difference between equations and inequalities, in an equation, typically there's one answer, one point. With inequalities, typically there's infinitely many points. So just keep in mind that coordinate plane would extend forever. And you could test this. You could pick a point from that shaded area and plug it in and check and make sure it makes both of those inequalities true. All right. Well, let's jump down to example 2 here. And now we have lines. All right. So on both of these, I want to graph these as they are normal lines. And I'm going to kind of signify, I'm going to do this one in black, and I'll do this bottom one in blue. All right. So I want to graph y is less than 2 minus x. So the y-intercept is 2, and the slope is negative 1. So let's graph it like a normal line. Let's put the y-intercept at 2, right here. And then down one, right one, down one, right one, down one, right one. Now, another main difference aside from the shading, if the inequality sign is not equal to, if it's just less than or just greater than, like this here, we actually use a dotted line instead of a solid line. And try to think about what the dotted line means. Try to think about what that means. Compare it to when you do normal inequalities, you think of the open circle and closed circle. That's what the dotted line and solid lines represent. A dotted line means the points along that line don't satisfy that inequality. They don't make it true. If I would pick a point from that dotted line and plug it in, it actually wouldn't make the inequality true. It's like a boundary line, a border line, but those points don't work. Well, now I need to shade one direction or the other. Here's a little shortcut. If it says y is less than, if it's less than or equal to, you'll shade below that graph. If it's greater than or equal to, you'll shade everything above. So this one says y is less than, so I'm going to shade everything below it, nice and light, just get an idea of where all those points are right here. I don't shade it dark because that might not be my final answer yet. Now, I want to graph the second one. So I need to solve for y. So subtract x and divide by negative 2. And keep in mind, with inequalities, if you divide by negative, you have to flip the sign. So y is greater than or equal to positive 1/2 x plus 2. Y is greater than or equal to 1/2 x plus 2. So my y-intercept's 2, same y-intercept, and my slope's 1/2. So up 1 over 2, up 1 over 2. It's equal to, that means it's going to be a solid line, and it's all the points above, because it's greater than. It says y is greater than, so everything up here in blue. Everything above the line. I pretend like the first line is not even there when I do the second one. Now I look at them together and I try to find the points they have in common, where I see blue and black. And you notice it's in this section right here. So to signify my final answer, I just shade that section in, nice and dark. And there we go. And I could test them. I could pick a point from that section, plug it in, and make sure it makes both inequalities true. You have that option. You can always test. All right. Let's jump down to example 3. So now we have 3 of them. All right. Okay. Well, take a look at the first one. This is where some of our previous knowledge is going to have to come into play. Think about what that equation, if it was an equal sign, would graph as. We've graphed these before, first semester. Think about what that would be. And hopefully you're looking at that, and that reminds you of the equation of a circle. If you think about the equation of a circle, that's x minus h squared plus y minus k squared equals r squared. That's the equation of a circle there. And the center of that circle would be at 0, 0, and the radius is 6. So I'm actually going to draw that circle. I'm going to put the center at the origin, and then the radius is 6, so I'm going to go up, right, down, and left 6 in all directions. 1, 2, 3, 4, 5, 6. Go right 6, down 6, and left 6. And then just draw a circle as best you can. Keeping in mind, if it wasn't equal to, we would do a dotted circle. That still happens for circles and other shapes. But it says greater than or equal to, so it's solid. Okay. Well, it says greater than, so try to think about where, use some logic. If greater than is typically above, think of a circle as being outside of the circle or inside the circle. I either need to shade outside or inside. Since it's greater than, try to think about where you would shade, outside or inside. Hopefully you think of outside. So I'm just going to draw little sun rays here a little bit. Beautiful. It's gorgeous. So everything outside of that circle makes the first one true. Okay, so nothing inside the circle will work. Well, now I'm going to graph the next one. So I have y is less than or equal to 3x plus 10. I'm going to do this one in red. So up 10, put a point. And then I would normally go up 3, right 1. Instead, I'll go down 3, left 1. It's equal to, so I'll draw a solid line. And it's everything below that one. It says less than. It says y is less than. And everything below is over here. Okay. Now I have one more. So I have negative y is greater than negative 2/3 x plus 5. Subtract 2/3 x to the other side. And divide everything by negative 1. So y is less than, you have to flip the sign, 2/3 x minus 5. Remember to flip the sign. My y-intercept's negative 5. 2, 3, 4, 5. And then I'll go up 2, right 3. And you can go down 2, left 3. And also, this is going to be a dotted line because it's not equal to. So I'm going to do a dotted line here. So the points along the line don't work. And it's going to be everything below. It says less than. So everything below. So stay outside the circle there. Alright, so now we really need to be careful where we shade our final answer. So it's everything outside the circle below the red, and below the blue. So we use the lines and the circles as kind of a border. So it's got to be below the red. I should use black. Below the red, below the blue, kind of like I'm coloring inside the lines, and outside the circle. So I'm going to just border. Notice I won't go above the blue. So there's my border. It's got to be everything below that border right there. So I just shade that section in nice and dark. La-di-da. Those are all the points that make all three inequalities true. So again, we had to know how to graph a circle. We had to know that greater than is outside the circle. We had to know that sometimes you have dotted lines. And then keep in mind where to shade. I mean, you need to keep your work organized on these problems. Okay, let's go to the next. Okay, two more. So again, I look at this first one, and I have to identify what type of inequality that is, or equation that is, and that is the equation of a circle. There's my center there. All right, so this is going to have center at 0, 0, and radius of 5. The center would be 0, 0, and the radius is 5. So I'm going to go 5 in all directions from the origin. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I draw my circle, but be careful. Notice it's not equal to. It's not equal to, so I need to draw a dotted circle. My voice just cracked. Enjoy that. So a dotted circle. And it says less than. So this is the case where everything inside the circle is going to work. And I just shade nice and light just to get an idea, to remind myself it's everything inside the circle. That shading is kind of irrelevant because we want the points that make both true. So just shade inside nice and light. All right, the second one, let's solve for y. I'm dividing by -3, so I have to remember to flip the sign. So greater than or equal to 4/3 x. The y-intercept is 0. Nothing's added on the end, so the y-intercept is 0. And I will go up 4, right 3. And you can go down 4, left 3 if you want. Solid line because it's equal to. Don't forget about that. And it's everything above. So everything above this red line. And I'm trying to find all the points that they have in common. So that's going to be everything inside the circle and above the red line. So everything right in here. Notice the points on the circle don't work though, because it's dotted. All right. Last one. Last one we're going to do. Okay. So on this one, I have 3 again. Notice on the first one though, it's not a circle. Only one of them is squared. So now you need to think about, okay, what would this be? Well, this is going to be a parabola. If you recognize you have a y and then you have an x squared, that's going to be a parabola. And also, this negative in front of the x squared tells you that it's going to be an upside down parabola. Okay. So what you're going to do, I'm going to mark where the center of this is, right there, the origin. All right, I'm going to graph this parabola. And what you can do, and what we've done when we've graphed stuff before, is make a little table of values to figure out where we're going to graph this parabola. If you want to use your graphing calculator to get that table, that's fine. But I'm going to put in some values for x, just to get an idea of what's going on, and get y values. So I'm going to put -2, -1, 0, 1, 2 in for x, and get some y values to plot, just to see exactly where this parabola is. So if I put -2 in for x, be careful with that negative there, because it would be negative and then -2 squared. So that would actually be -4. And then if I put -1 in there, oh shoot, I need to add the 2. So that would be -4 plus 2 is -2. And if I put the -1 in, well, that's going to be -1 plus 2, so 1. If I put 0 in, plus 2 is 2. If I put 1 in, negative 1 plus 2 is 1. And if I put 2 in, I get negative 4 plus 2, negative 2 again. So I'm going to plot those 5 points. Negative 2, negative 2. Negative 1, 1. 0, 2. And then the other 2. 2, negative 2. So there's my parabola. You see it's upside down like it should be. And it's equal to, y is greater than or equal to. So I'm going to draw a solid parabola. Right here. And it says y is greater than. So you can think in terms of above or below this parabola. Y is greater than, so everything above is basically going to be everything, you think of it in terms of inside and outside, everything outside this parabola. All right. Now we have x is less than 3. X is less than 3. So that's going to be a vertical line crossing the x-axis at 3. And it's going to be dotted because it's not equal to. So right here, it's going to be a dotted line. And it's less than, so it's going to be everything to the left. Everything to the left. Lastly, y is less than or equal to 1. So I'm going to draw a horizontal line crossing the y-axis at 1. And it says less than, so everything below. Everything below. So here's where you need to be careful, because there's actually 2 sections that work. It's hard to see the second one, but the 2 that work, well, this one's kind of easy to see. This section right over here, outside the parabola, to the left of the red and below the blue, is over here. There's also a tiny little sliver right over here that I'm going to start coloring in that also satisfy all those conditions. Right here. That's everything below the blue, left of the red, and outside the parabola. So when you start getting into different shapes and figures and multiple, you really need to look out for where that shaded section is. But a couple things to keep in mind conceptually. Understand you are finding many, many, many points that make all of the inequalities true. And also understand a dotted line means those points don't work along the line. It's like a boundary line. And from here, you guys are going to have your assignment to practice. So if you have any questions, just message me on Canvas or email me, and I should be pretty quick to respond. Have fun.